Thank you, Antonio. Hope everything is fine into the presentation. And thanks for the nice introduction. So my name is Marc Castaing. I'm the head of the Laser Sources and Components Department at ALPhANOV. And today, definitely we are not specialists in the terms of fiber sensing, but we have a set of competencies I would like to advertise and propose to the community to discuss about maybe potential of new fiber-based sensor application based on specialty optical fiber, femtosecond laser inscription. What could be the merging of these two things? So just to give you an insight, ALPhANOV is a research technological organization which has been founded in 2007. It's a non-profitable organization. We are roughly 120 employees, mainly localized in Bordeaux area in the southwest of France, with some offices in Limoges. And we're 4 technological departments. So it's the Laser Sources and Components department that I'm heading. Some photonic system department where their target is to make some integration of complex systems, optical system based on the lasers, and make some custom machines. The laser processing department where their expertise is really what you know, Antonio, about cutting with high precision, drilling, making some in-material modification with femtosecond lasers. But we also have a training department, training centers for making some training and custom training for related to laser and laser technology. So today I will just introduce the competencies of my department, and to give a bit of history. Actually, the basis of my department is really specialty optical fiber interfacing. So based on photonic crystal fibers, we have developed a specific know-how and knowledge on how to interface these very non-standard fibers that Christian gave some examples with his polymer fiber, microstructured one. And based on this knowledge, we moved to mostly to go to some high-end components, fiber-based high-end components based on these specific fibers. And since more than 3 to 4 years, we have also developed some capabilities in terms of femtosecond laser inscription into fibers. We also have some specific expertise in precision gluing and aligning, making us capable to make some new kind of fiber-based components, but fiber-based feature based on micro-optics inside this kind of box. But all this realization, as of today, is really oriented to make some components for laser or custom laser development. And that's why today, with this opportunity to present a bit of our know-how, I would like to try to address the community of the fiber-based sensing to see whether some of these competencies could be used for fiber-based sensing. So I made a selection of 2 topics I would like to highlight a little bit, or expertise in specialty optical fiber interfacing. So when we talk about specialty optical fiber, we are mainly talking about this kind of photonic crystal fiber, and we are addressing the whole zoology of this kind of fiber, meaning the hollow core fiber, some LMA, layer to mode area fiber, which are endlessly single mode. I will come back to it afterwards. Also some very small core diameter fiber, which are aiming at making some nonlinear effects into this fiber, or also some amplification fiber. As you see, all this fiber, we are capable to do many things on that. Some end capping, some adaptation between this kind of very specific fiber to standard fibers for decreasing the losses in coupling and to make it still all fiber. We have capabilities for making taperization or extremity functionalization like green lens, ball lens. And I was thinking that maybe this kind of fibers, the hollow core ones and the endlessly single mode ones, could be of interest for making some fiber-based sensors. Because an hollow core fiber is a fiber in which you are guiding the light into a core which is made of air. But this kind of fiber can be filled with any kind of species, liquid or gas, that we would like to maybe analyze. And it might be of interest for maybe inline monitoring of flow into some industrial applications. And the endlessly single mode fiber are the good point to have the capability to guide light over a broad spectrum, still in a monomode favor. meaning that, for instance, this kind of fiber can guide light from 500 nanometers up to 1.7 micron and 1.8 micron. So if you want to make kind of a sensor which would require different wavelengths for addressing some different sensitivity, these kind of fibers are far better than the regular ones, which have cut off bandwidth of roughly 200 nanometers in single mode behavior. So that's the kind of know-how in terms of interfacing we could propose. And this kind of know-how, we could also join it to some femtosecond laser inscription. So I don't know if everybody in the room is really familiar with that, but the idea here with femtosecond laser inscription is to take benefit of the fact that we are using a femtosecond laser, which has a very high peak power, to focus it into the core of a fiber, and then you can have a very localized modification due to the nonlinear effect, multiphoton absorption effect, which is illustrated in this picture compared with linear absorption in the UV. And so you can have really very precise modification in the core of the fiber. And the good point of that is that you do not need to have any photosensitive agent to UV of the fiber. This means that you can address any kind of material somehow to make this volume modification and to write this refractive index change. So this kind of techniques is already applied because it's compatible to extreme environment if you're taking, for instance, silica glass, and because the kind of FBG you can write inside the fiber will be not too much sensitive to temperature or even radiation, because you can really write into pure materials. So we are in this set of making this kind of components since more than 3 years. We have a couple of stations of different kind, point by point, Talbot or phase mask. So we can do more or less any kind of components like standard FBG, TFBGs, tilted FBG, chirped one, even P-shifted from visible to mid-air. And we can adapt to the material which is required by the application. We also made lots of testing of all fiber Fabry-Perot cavities. So for all the experts in the room who are used to FBG sensors, I would say we have the capabilities to write these kind of things into any kind of material. But the question is, would it be interesting to merge that with a specialty optical fiber that I described below? And the third point is, with this kind of station with a femtosecond laser inscription, you can also write waveguide in bulk materials. And with this kind of waveguides, you can also make some kind of sensors based on evanescent coupling of light. And we have capabilities to make some custom beam shaping so that we can make this fast inscription. We can make low loss waveguides. And we have also capabilities to make fiber coupling of this kind of bulk materials. So I would say we have 3 points here. We have the capability to interface specialty optical fibers. We have capabilities to make some femtosecond laser inscription into these fibers or into regular fibers. And we have capabilities to make some coupling in between the different elements. And my feeling is that based on all these things, we could maybe reach some new kind of generation of fiber-based sensors. And as an illustration, I would like to highlight that with a European project, which is currently under development. This is an European project, which is a FET open one. So it's part of basic science with different universities in Italy, in Hungary, which are making some basic science and kind of theoretical things. But the idea of this project is really to use hollow core fibers, which would be filled by rubidium atomic vapors. And our task in this project at ALPhANOV is to make the interface of this kind of hollow core fibers with regular fibers, to make some specific FBGs, to make some field enhancement into the hollow core fiber. And the main goal of this is to make new kind of sensors, quantum-based sensors based on these alkali vapor field cells. And for this kind of project, we are technologically working with Glow Photonics, who is providing the hollow core fibers. and the XLIM laboratory, which is in charge of developing a way of filling with atomic vapors these kind of fibers. So this is an illustration for the very high end, talking about quantum sensing. But I'm pretty sure that by merging all these competencies we do have regarding the specialty optical fiber technology and the femtosecond laser inscription, we might be able to address maybe some new kind of fiber-based sensors. And that's really the kind of competencies I would like to advertise today, so that if you have troubles, problems, or to submit to us where we could maybe think about potentialities of new components. And this is just talking about our core competencies in terms of components, but we have also capabilities to develop some lasers for making interrogators or specific interrogators. And at the scale of ALPhANOV, we also have this photonic system department, which could be also in support for making a new kind of interrogators. So yes, today the idea is really to demonstrate what we're capable of, and so that we can really have exchange about your problems and maybe solutions we could bring with our competencies regarding specialty optical fiber and femtosecond laser inscription. Prior leaving the floor, I would like to make a quick advertisement for a quantum sensing event, which will be held in the frame of the CRISCube project. It will be held in June in Limoges, and it's an opportunity also to discuss about maybe potential applications of this kind of quantum sensors, but also a potential application of this kind of technology for sensing in a more larger way. So it was short, and the idea is really to be eager to learn about your sensing problems and to see whether we can support you in some developments.
Thank you, Marc.